Hello, and welcome to this presentation on being cloud ready, mass secure onboarding for the IoT. My name's Haydn Povey. I'm CEO of Secure Thingz, an IAR systems company. So let's start off by looking at the problem statement around IoT security and cloud connectivity. In terms of IoT product security, the first thing to understand is that embedded computing is dead. Or if not dead, then at least rapidly transitioning to edge-based computing, with the difference in being the constant connectivity to the internet, the ability to do real-time event reporting, system monitoring and sensor status, and of course the ability to remotely control devices, including pushing updates. Fundamentally, to enable these, we have to have the 5 core security principles baked into the DNA of every device. Confidentiality of data, integrity of the system to ensure that only properly signed and encrypted applications can be run. High availability, so presuming that we are going to be under attack and we need to be robust and resilient. Of course, authentication is a key component alongside authorization. Of course, at the other end of the connection, leveraging the cloud and leveraging the right cloud provider is critically important in reducing infrastructure costs, minimizing development times, and delivering scalable infrastructure that has a very high uptime or availability. Many people are looking at on-premise cloud capabilities to reduce privacy and latency issues, although these are being tackled, of course, by the latest technologies. The number one challenge, though, for the IoT cloud vendors is really how they onboard billions and billions of devices. How can you know what is trying to connect to your device, what rights it has, what services the OEM has or end customer has paid for? So how can we make our IoT products and the IoT product security cloud ready out of the box? How do we ensure that IoT devices are secure from birth and that only trusted devices can connect and interact with a trusted cloud? And also, how do we measure risk, which is a critical metric for customers' networks in the cloud? To achieve this, security must be configured inside the design process. We need to protect and lock down the device with a secure boot framework. We need to ensure all code and updates are formally signed and encrypted. We need in-production provisioning, leveraging X509 certificates, PUF or equivalent. And we need to integrate cloud valeting to ensure manufactured devices are known to the cloud. And we will look at those aspects over the next few slides. Fundamentally, though, Secure Thingz delivers a trusted platform which achieves this rapid cloud onboarding. So, there are 4 steps to secure cloud onboarding. Step 1 is to identify or build a relevant PKI structure. You may self-sign or you may use a third-party CA. And this is used to obviously establish a chain of trust. Step 2 is to configure the cloud infrastructure and upload intermediate certificates to the cloud to enable a pre-knowledge of the devices to be produced. Step 3 is obviously securely provisioning devices during manufacture and production, whether in-house or in a third-party distribution partner. And step 4 is to automatically onboard products at first connection. In terms of these 4 steps, the first then, identifying and building a PKI infrastructure, can be done easily through embedded trust. And we'll demonstrate over the next few slides exactly how we do this, but it really forms part of the baseline security context within the tool. We can then set up the cloud infrastructure and upload certificates using an IoT solution helper tool built into Embedded Trust. And this helper tool will upload the device trust anchor certificate to the cloud from Embedded Trust security configuration. So this is known so that the cloud can authenticate devices when they're onboarded. Step 3, the secure provision of devices at production time, is done using our secure deploy platform, which provisions each device with a unique identity based on a framework that is chained back to the trust anchor in the cloud. Again, this is a very standard component of our platform now, available both on desktop and in high volume form factors. And then the fourth step, of course, the automatic onboarding, using an application modified to work like the supplied examples. Devices use their provisioned identity in order to register with the cloud on first power up. This is a just-in-time process, but the cloud is aware of those intermediate certificates and can leverage them easily. So let's go and investigate that flow in a bit more detail. First of all, building the PKI infrastructure. Why certificate chain? Most people listening to this today should understand that implicitly. But basically, the certificate chain provides a root of trust to all of the IoT devices. And the framework is required as part of that process to go into production. Every device has a unique identity, certificate, and private key, which is chained back to the trust anchor. Embedded Trust can integrate or implement this chain. You can easily import CA certificates into the tool, and Embedded Trust will export the certificate chain framework to the secure deploy production system, implicitly delivering the unique identities onto every device. So if we look at the flow here, we have Embedded Trust and IAR Workbench creating this framework of the root certificate, which is trusted by an intermediate certificate, and that is inherently trusted by these unique device certificates, which are milled out into each and every device. When we look at setting up the cloud infrastructure, this can actually be quite complex to achieve in practice. We need to create and configure the IoT services, we need access points for web applications, and we need to have the device signing certificate, the trust anchor, uploaded to the cloud and registered properly. And this inherently typically involves a challenge to prove ownership of the certificate. The Embedded Trust now simplifies this cloud setup with a helper tool for add-on services, which you can go back and you can tweak, and it automatically uploads the necessary certificates for the security configuration. If we look at the diagram here, we have the Embedded Trust tools down in the left-hand side, and that again generates this certificate chain, the root, the intermediate, and the device template. The add-in sets up the IoT resources and servers, whether this is for AWS or for Azure, and uploads the device signing certificate to the cloud, which is a form of intermediate certificate. The device template, with all of its information, is sent through the secure production flow with secure deploy to the factory, and again every device is individually milled out and secured into the device. And this means that each of the devices are provisioned in such a way that onboarding and data exchange can easily be integrated into the cloud. Importantly, each unique device produced needs its own identity. It's a public certificate with a private key pair. Secret data just simply cannot be exposed in the factory if we are going to protect our devices. Here, Secure Deploy platform really meets this challenge. It uses a HSM to securely provision all the software and certificates. Protection is guaranteed inside even insecure factory environments. Embedded Trust exports directly to the production flow, and all of the credentials and frameworks are inherently secured and authenticated to only the HSM which has been targeted. This flow ensures that every device identity is truly cryptographically unique and secured. So again, here we can see Embedded Trust with the security configuration, our security context. This is all protected and exported through Secure Deploy into our hardware security manager and thence into the device being programmed and provisioned. Device onboarding is complex, and it is impractical to onboard devices individually. So by setting them up in this framework, we deliver a just-in-time bulk onboarding capability, and on first power up, the devices connect to the cloud and register using their unique identity. This is done using a standard TLS connection, and it basically ensures that the devices just appear, are known, are accepted and onboarded correctly. And we have a demonstration here using the root of trust inside a number of our silicon vendor partner devices, and leveraging common RTOS platforms, including FreeRTOS and Azure RTOS. Again, the diagram here demonstrates that with the root certificate structure being uploaded as the intermediate, the SBM and other secure example being integrated into the device and then identified up to the cloud. So finally, let's have a look at some more of the product details here of how this is achieved. So inside of Embedded Trust, we have the PKI infrastructure creation here. And this identity map here demonstrates how the device certificate is related to the intermediate and related back to the root. And we can go in, we can edit this as we have here with the certificate identity data, or we can replace it, as I say, with a third party. This enables us to create certificates and store them inside the security context or security profile, along with other important security information. In terms of setting up the cloud, we have a very simple command line instruction here, because this is typically quite an advanced user capability. But also inside of Embedded Trust, there are helper tools for common cloud platforms such as AWS and Azure. And this allows the full cloud setup, registering a certificate from ET, and including the X509 certificate parsing and signing. This allows us to migrate from development to production very, very rapidly. And in fact, out of the box, this is all possible inside of half an hour, enabling us to configure our devices and our security context, our application, export that through to the Secure Deploy platform, either secure desktop on the desk or in high volume, and subsequently through to provisioning in the factory. So the Secure Thingz Cloud support is available today for creating PKI infrastructure, device identity, the secure boot and production export, and is available for Amazon AWS with the helper tool for AWS Cloud Setup, and a full demonstration security application for the STM32. The Microsoft Azure IoT Cloud support is available for demonstration now and will be formally released early in next year with a full Azure IoT helper tool, integration with Azure RTOS, and a full demo application. Thank you very much for your time today and attention. At Secure Thingz, we're very pleased to really focus on all aspects of security for the IoT, but really enabling our partners to meet some of these big challenges around onboarding, IP protection, malware, and lifecycle and update management. Thank you.